Okay, guys, so we're going to do a video on unit circle. Um, Unit circle seems to be kind of a little bit of a struggle when you first look at it, but it's really easy when you break it down into really small pieces. So let's kind of talk about the basics of it. What we have here is we have really a circle that we already are familiar with, 0 to 360 degrees, and we've already been doing various different angles using that information. So here we're going to actually apply a whole bunch more to it. Okay, so right here we have 0 degrees. We already know this is 90 degrees because that's a right angle, and this is 180 degrees. I'm going to make this skinny. And then here we have 270 degrees. And then here we have 360 degrees. Those are all ones that we're really familiar with. Now what we have halfway between 0 and 90 is 45 degrees. Halfway between 90 and 180 is 135 degrees. Halfway between 180 and 270 is 225 degrees. And then halfway between 270 and 360 degrees is 315 degrees. So I will give you a unit circle on your tests and quizzes and everything, but the thing is that it's not going to have the degree measures on there. So we have to know how to get those degree measures so that I can use them, okay? So those are the easy ones, and then you have to remember that these are 15 more and 15 less. So 15 less than 45 is 30, 15 more is 60. 15 less than 135 is 120. 15 more is 150. 15 less than 225 is 210. 15 more than 225 is 240. We got 315, so 15 less is 300, and 15 more is 330. So now I have all of the degree measures filled out throughout my entire unit circle, 0 to 360. What I can do then next would be to translate each of those degree measures over into radians. So there's several ways to do this. One of my favorite ways is just to kind of look at this and realize that if I count by pies, so let's take a look right here. I can break, and let me make this a bigger one. I can break this down right here into threes. So like if you think about a piece of pie or a piece of pizza or a big pizza, I have 1, 2, 3, 4, 5, 6. I have 6 of this right here. So I can break this all down if I know that this is pi, because we've already discussed that 180 degrees is equivalent to pi, and this is 0 radians. So I'm going to break this down into 6 different ways. So this is pi divided into 6 pieces. This is 1/6 of pi. And then right here, I have 2/6 of pi. Here I have 3/6 of pi. Here I have 4/6 of pi. I have 5/6 of pi. And here, 6/6 of pi. So if I break a whole number 6 down into 6 pieces, I have 1, 2, 3, 4, 5, 6. Now I just need to reduce these fractions. So 2/6 over pi, or 2 pi over 6, that's going to get me pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 is going to reduce to 3 pi. Oops, that's got really big. Oops, sorry. Thinking about the wrong thing. 2 pi over 3. 2 pi over 3. 5 pi over 6 I can't reduce, and then 6 pi over 6 equals pi, which I already had written right there. Okay, so if you notice, all of the things that are on my 30 degrees, so 30 and 150, these are 30 up from 180 and 30 up from 0, both have a denominator of 6, and the ones that have the 60 right here would be denominator of 3. Okay, I can do the same thing down here. We know that an entire circle is equivalent to 2 pi. So I'm going to break this also down, and I'm going to keep going. So I stopped at 6 pi over 6, so here I'm going to make this 7 pi over 6. Then right here I have 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So again, on every 30 degrees, I'm doing it. So I'm ignoring those 45 degree marks, okay? So only those 45s I'm ignoring, and I'm doing this every 30 degrees. Now I just need to reduce these. I can't reduce 7 pi over 6, but I can reduce 8 pi over 6, and that is now 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6, well, I don't know why I erased that one. That one doesn't reduce. I was just rolling with it. And then here, 12 pi over 6 reduces to 2 pi, because 12 divided by 6 is 2. So now I have all of my 30s. So then now I can fill in with my 45s. Do you have to do it this way? No, of course not. You can also do it just by using the way to translate from degrees to radians, where if I'm given degrees, I just multiply by pi over 180. You can do it that way. That is perfectly fine. I'm just trying to get a little bit of a shortcut, if you will. All right, so now to do the 45s. So here I would take pi and I would divide it up into 4 pieces. So like right here, 1, this is one big one, this is another one, this is another one, and this one right here. Wow, those are really bad lines. But you can see 1, 2, 3, 4, right? So what I'm going to do now is if I'm taking pi and I'm dividing it up into 4 pieces, I have 1/4, 2/4, 3/4, and 4/4. So pi over 4, I can't reduce that. 2 pi over 4 reduces to pi over 2. Hey, we already had that. 3 pi over 4, I can't reduce that. And 4 pi over 4 reduces to pi. So I'm good there. So now let's try the bottom half here. So if I left off at pi right here and I kept counting, that was 4 pi over 4. Now this is going to be 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, I've got all of those, so now I just need to reduce what I can. Well, I can't reduce 5 pi over 6. 6 pi over 4 reduces to 3 pi over 2, which is what I already had. I can't reduce 7 pi over 4. 8 pi over 4 reduces to 2 pi, which is also what I already had. So now I have my degrees and my radians all filled in. Now I just need to figure out what the coordinate points are. So what I gave you guys when I did all of this in class was I gave you 3 triangles and gave you the information. Right now I'm just going to go ahead and just fill it in. And if you have questions and you need to actually see why something is, come see me, if I'm being honest. So now I have square root 3 over 2 and 1/2. Square root 2 over 2 and square root 2 over 2. Here I have 1/2 and square root 3 over 2. This is going to be 0 and 1. This is negative 1/2 and square root 3 over 2. This is negative square root 2 over 2 and positive square root 2 over 2. And this is negative square root 3 over 2 and 1/2. Notice these right here at the 30 and the 150, those are the exact same coordinates, except this one has a negative on my x. If I look right here at my 0, I'm going left on my x and I'm going up. And this angle right here is the same as this angle right here. So that's why that's happening. So down here, I got to remember right here, this has a radius of 1. So if I start at 0 and I go left 1 and I don't go up or down, I have negative 1 and 0. Here I have positive 1 and 0. So down here, this one is going to be negative square root 3 over 2 and negative 1/2. So see, it's the exact same numbers as up here. For this one right here, it's just both of them are negative now because I'm going left on the x and down on the y. Here, this is negative square root 2 over 2 and negative square root 2 over 2. Here I have negative 1/2 and negative square root 3 over 2. This one is going to be 0 and negative 1. Then here I have 1/2 and negative square root 3 over 2. Now I have square root 2 over 2 and negative square root 2 over 2. Square root 3 over 2 and negative 1/2. Now I've filled out my entire unit circle with all of my radians, all of my degrees, and all of my coordinates. Now we need to talk about what everything is. So on your unit circle, you're going to have these coordinate points where right here, all of my x coordinates are cosine, all of my y coordinates are sine. We can easily see that represented right here in this. Let me show you this right here. Oops. Oh, here, let's just use this one. This one's already filled out. So if I was to go ahead and go along this one right here, where I go 30 degrees and I create a triangle right here, this is the 30 degrees right here. My horizontal value is square root 3 over 2. My vertical value is 1/2 because this is horizontal, this is vertical, and I have a radius of 1 because it's a unit circle. Sine is opposite over hypotenuse. Opposite over hypotenuse. So sine is 1/2 right there. Cosine is adjacent over hypotenuse. So square root 3 over 2 over 1. Cosine. So all of your cosines and sines are right there. Tangent is opposite over adjacent. So tangent is going to get you sine over cosine. Those are your big things to be able to remember what to do with those, okay? So now that's your whole unit circle. On the next video, I'll show you how to use the unit circle.